All right, welcome back. This is part 2 of the throwable object tutorial. The last one, if you haven't done it, go ahead and go back and do that. Otherwise, you're in the right place to continue along. In this video, we're going to finish up that throwable module, and we're going to build some new states for our player for lifting and carrying the objects. Hi, my name is Michael. Welcome to my 2D action and adventure RPG tutorial series. Follow along and learn how to create your own ARPG in Godot 4 using GD script. Now, before we can use these animations, we want to build our new player states so that we can utilize it that way. Okay, so we know we're going to need some new states in our state machine. We'll start by creating 2 empty nodes for both of them. And the first state will be the lift state, which will correspond with our lifting, and then the second one will be the carry state, right? And so we're going to build those, and then obviously each state will play the appropriate animations and do all that, okay? And again, our lift state is kind of going to be pretty basic. So let's create a script for our lift state. So let's go down here to our file system, and this is going to be underneath our player folder, right? Player, oh, that's props. Player, script states right in here. Okay, here we go. New script. We'll call this, I guess, state underscore lift. Okay, we'll give it a class name. Except no capital C there, buddy. Okay, class name state underscore lift. And this extends a state. Okay. Now, we don't need to do a whole lot. In fact, part of me still wonders if it would be good to just combine this with the carry state, but there are some benefits to keeping this one separate, even though it's super simple. We're only going to need a couple things. So I'm going to export a variable, which is going to be the audio that we play. So we'll just call this pickup audio, or not pickup. Don't use that term, Mike. Lift audio. So we'll just call that, and that'll be an audio stream resource. And then obviously we want to know the next state. We're going to need a reference to it here. So you can see that this is getting a reference to our carry node. And hold on, I need to save this because we haven't assigned our lift state. Let me first save it and put the lift state over here on lift. Okay, because that's an incorrect reference to that location. Okay. Now let's try that again now that it's part of the scene. Okay, that looks better. It's referencing that sibling node. Okay, so this is a state, or it will be once we get there, okay? Because that'll be the next state that we get to. And then we can always come in here to our base state node and just copy all the functions over here and paste them in, okay? Now we don't need to do anything in the init. So in fact, you could just remove that if you want to, or you could leave it. And on enter, here's what we're going to do. We're going to get our player. And we're going to say update animation. And we want the pickup or the lift, the lift animation. You couldn't tell, I couldn't decide whether to call it pickup or lift. Okay, so this is the lift animation that we want to play. And then what do we need to do? We just basically need to play the animation. And then once it's complete, we can go to the carry state. Okay, so let's do this. Let's say player.AnimationPlayer, and let's listen for this animation finished signal, right? Because we've got an animator. When the animation finishes, we'll connect to that. And then we're going to just create a function in here, and we can just call it state complete. We could spell right. That would be pretty handy, but okay, state complete. So let's create this new function down here at the bottom of the script. And then because this is connecting to that animation player signal, it is going to give us the animation name, which is a string. Okay. And we'll come back to that in just a moment. Before we do that, let's finish our enter function here. We do want to do one other thing. And let's just grab our player. We've got an audio player. it's just stored as audio. So the stream, we'll set the stream of that audio player equal to the lift audio, and then we can just play it. So player.audio.play. Okay, cool. So there we go. And we've got our simple state machine here. In the process function, what we want to do in this one is just keep the velocity at 0 so that the player can't move. So we'll just say player.velocity equals vector2.0. There. Now the player will not move. And then state complete. Let's just come down here to state complete. What we want to do is we want to disconnect. In fact, let me just copy that line. We've connected to a signal. We should disconnect from it. Okay. And then all we need to do is say state machine dot change state, and then we'll just put in the carry state. Okay. We'll pass that in. Now, if we were to try and run this right now, wouldn't work because we don't have a carry state. So we should start building that. And keep in mind also that we aren't actually yet calling or making the player enter the lift state. Okay, that's just kind of there. What we should do though at this point is we should build a way for our player to get into the lift state. Okay, because our throwable object doesn't really have a concept of the player state machine. And so I don't really want to put any states in there because that could become a little bit complicated to manage. So let's look at our player. Let's start with our player script. Our player has knowledge of the state machine. Okay, so what we can do within our player is let's create a new function. We'll just call it pickup item. And this item needs to be of type throwable that we're going to pick up. And we want to pass that in, I guess is what I meant to say there. Okay, this function will not return anything. So then what we can do is we have a reference to our state machine. So we can say state machine.change state, and then we want this lift state, right? So let's actually go ahead. Let's go up here and let's get a reference to our lift state. Okay. And then now we can come back down. So we'll pass in, not list, we'll pass in the lift state. We're going to change to that state. Well, we're going to want to do a little bit of extra work here. Like we want to be able to keep track of the throwable object, and we might need to do something here, but you know. But other than that, we're good. Okay, so this will help us be able to enter that state. Now let's save that. We need to bring this full circle. We do need to go back to our throwable. So when our player interacts, we need to begin adding some code here. Okay, and there's going to be a few things we need to do. But to test this, the first thing we can do is we want to add the item to the player and tell the player to enter the lift state. And let's start by just doing entering the lift state, because that should trigger that animation. So then we'll know if it's working. So let's say player manager.player, and then we'll say pickup item. And if you recall, we wanted to pass in the throwable to that pickup item, which is this node, this script. Okay, so we'll just pass it in ourselves. So this should get us just partway there. The other thing that we want to do is we've connected these signals. Once we lift up an item, we need to disconnect from those signals. So let's just go ahead and take care of that now, because otherwise, obviously, you push the lift button and it'll keep trying to run this code, and that's just pointless. Okay, and I'm going to save this, and let's just run the project and see what happens. We may run into, yeah, that's what I thought. We may run into an error because our carry state doesn't exist yet. Okay, let's stop. Let's do that. Let's create our carry script just so we can get this moving, and then we're not going to do much with it, but we'll call it state_carry. Open that up. Give it a class name, and then it extends state. Okay, now that should be enough to get this warning cleared. Let's see here. Oh. Okay, carry. We do need to apply that script. If this doesn't do it, I hope you heard the sneeze. Okay, there we go. Now, I forgot to turn that sprite off, so ignore that for just a second while we're testing. Hey, look at that. It animated. Now we're stuck. We're stuck in this state. We can't do anything. But what's nice is it played that animation. So we know we entered the lift state. And in fact, we don't even have any errors. It entered the lift state. And then if our code worked, it's hard to tell because the carry state does nothing. We probably entered the carry state. And if we were debugging this out, we would see that. Okay, but that's a good sign. That means things are beginning to function. Okay, we're going to run into more issues and more things we need to do here in our throwable, because we need to do more than just pick up the item, because this does not move the item to the proper location or anything like that. Okay, so let's just maybe handle just a couple of those bits of items and get this one step further, and then we can get onto our carry state. So how we're going to handle moving the object is we're going to say if throwable. So the throwable, now if we remember, I hope this isn't too confusing, but the throwable is actually the parent of this script, okay? But we want to check if the throwable has a parent, which it should, meaning whatever object that throwable is inside of it, which is going to be probably the level. So if the throwable has a parent, so if throwable.getParent, then we actually need to remove it from that parent before we can move it to the player. So we'll say throwable.getParent, and then we can say .remove child, and then throwable. It sounds kind of funny. We're going to get the parent of throwable and then remove throwable from it. Okay. And then once we've done that, or even if we didn't need to, if it didn't have a parent, then this next line of code is good. So it'll be outside of the if statement. So make sure that you're not indented on this next line. Then we're just going to go like this. We're going to say player manager. Let's see, .player. And then we have our we need our held item, don't we? And we don't have a reference to that. Okay, let me comment this out for just a moment. Let's go back to our player script and let's just get a reference to that up here. Okay, so we need this held item. Good to go. So now we can call that from anywhere. Let's go back to, let's go back to our throwable script. Okay, player manager.player.held item. Okay, so now we can go to this and say add child and just make it the throwable. Okay, so that's going to transfer the throwable from the level to this player's held item node. And in order to preview this, let's go to our player. Let's turn off this sprite. We can probably delete this. In fact, we will, but until we're certain that we don't need it for preview purposes, let's just leave it. Okay, let's run. So now if everything works, that sprite should move to the player. Oh no. Everything did not work. Okay, let me think for a second. What did we overlook? Oh, I know what we overlooked. This is actually a good bug to fiddle with. So if we look at the pot, let me just look at this pot here. It has a transform of 144 and 210. Okay, so it's from the origin here, it's over 144 pixels and down 210. So from where our player is, when we pick it up, that's like off outside the viewport. Okay, so we need to reset this transform as well when we get into our script. So let's come over here to throwable. And once we move it, let's go ahead and change the position. So throwable dot position. And in this case, we're just going to set it to vector 20, because we just want it to move with the position of that thing, and the zero position of our held item node is where we want this to be. Okay, so now if I haven't missed anything else, we should be picking up the object and done with all those little quirks. Boink, except the one where it bumps him. We'll handle that with the carry, okay? So there we go. Now all I can do is throw a boomerang, which maybe we don't want to throw a boomerang, but I'm not worried about that right now. But actually, yeah, let's do this. Let's take care of that collision, because you notice when we picked up the object, it kind of bumped the player around. And I'm surprised we didn't see more. In fact, let's try picking it up from like above. I think this is going to go haywire. This might be fun. Okay, yeah. Kicked him around. I'm surprised it didn't just keep pushing him. But let's fix that. We need to be able to disable the collisions. So we don't know what collision shapes we have, right? Because let's look at the architecture of our scenes here. Our throwable doesn't have the static body 2D that's causing that. It's here as a child of the pot. Okay, it's got a static body 2D. So this throwable is going to be the pot in this instance. And we need to find the collision shapes and get rid of them. So let's go ahead and just make a function to handle that. And we're going to just find any collision bodies and disable them here. So we'll say function disable collisions. And what we'll do is we'll just pass in a node here of any type. Doesn't have to be node 2D, just pass in a node. And then we'll go for C in node. So this is one of those common things that I do a lot. Node.getChildren. Not child, but children. So let's loop through them. And what do we need to do? First thing is we need to check if the object is a collision shape 2D. Okay. And then if it is, we can go c.disabled equals true. But there's a problem here because this is only going to go one level deep and our collision shape is here. But I want to make this a little bit more robust because what if in the future you made a new object and it wasn't a pot, it was something else, and the root object, so if the root object was a static body 2D, then this code would work. And I think that's good that we support that so that you could create, so the pot could be a static body 2D. In fact, we could change that right now and simplify it. But I don't want any hard and fast rules because it makes it harder to build things in the future, because then you got to build things a very precise way. Okay, so this will work in a situation that we're not doing. But if not, what we can do is we can make this check kind of recursive. It can go through the scene tree just a little bit. Okay, so if it's not a collision shape 2D, then we can have an else condition and we can just loop through, we can do something else. And what we want to do is loop through the children of that node. And we're going to call this exact same function. This is why we wrote it the way we did, because we don't know what node type we're going to pass in here. And in this case, we'll pass in C. Okay, so what this code is going to do is it's going to go sprite shadow 2D. Are you a collision shape 2D? No? Okay, well then let's look at your children. Oh, you don't have any. And then it'll go to the next one, sprite 2D. Are you a collision shape 2D? And it's going to go through, eventually it's going to get to static body. It's going to say, you're not a collision shape 2D. Let's look at your children. Oh, you have a child that's a collision shape 2D. Disable it. And it's going to do that through the whole scene tree. Okay, so this will go through our throwable and to disable that. And we don't necessarily want that. I don't think we want that. And we don't want to go through the children of the throwable because we've got a hitbox in there. Okay, so we can say if C is self. So if this child object that we're checking right now is this throwable thing, then we're just going to say continue, which means it's going to skip it and it's going to move on to the next node in the scene tree. In this case, there isn't, but let's just say the throwable is up here. Okay, then it's going to go down to static body 2D. We'll do that one next. Okay, that's what continue does. It just, in this for loop, just go to the next one. Go to the next child. Okay. I hope that makes some sense. This bit of code might be confusing if you're new to these for loops, but it works, and I think it's actually somewhat self-explanatory. This is the part that might be kind of weird, and this part, okay, because it's going to keep running this code. Now, you wouldn't want to do this if you had a scene tree that was full of dozens or hundreds of nodes, but in this case, we're pretty confident that we're going to be putting this on simple objects, right? It's things the player can pick up. We're not going to be doing this to the whole level, so we don't have to worry about it too much, okay? But if you did, then you might want to, then in that condition, in that case, you would want to build something where, okay, the collision shape has to be a child of whatever, and you can do that if you want. But in this solution, we built something that's more flexible, which I like. And then even if for some reason your static body was nested under the sprite 2D, would still work, okay? Let's go ahead and save that. So we've got our disable collisions function. Let's go ahead and call it. And we're going to pass in the throwable, which we should probably rename that. I don't know. But at this point, it's kind of late in the game. That's not this script. It's going to be the pot. So now if we run this script and go pick up the pot, it should no longer bump us. There we go. Player stayed in the same location. Okay. So mission complete on that one. Okay, so now that we get into our pickup or our lift state, and we are probably getting into our carry state, we should start building that so that we can move around and then eventually throw this, right? So the carry state is actually not that complicated. It's got a few little tricky things in there, but it's a pretty straightforward state. So let's just open this script. In fact, let's do this. Let's grab our code from our base state and let's go to our carry state. Let's paste that in there. Okay. And what do we need to do in our carry state? We just need a few things. We'll have two export variables. So our first one will be a move speed. So much like our charge attack, which we recently did, we want the player to be able to move, but this move speed is probably different than our normal speed. Now, of course, you're welcome to set it the same. Our regular move speed being 100, I'll set this to, in fact, let me set this to 100 and then we can adjust it as we see fit. So maybe you slow it down. And you could even make this a dynamic thing that comes from the object. You could set like a move speed modifier and adjust this or something. That would be kind of fun, but I'm not going to do that right now. We'll also have a throw audio, just an audio file that we play when you throw the object, okay? And we're not even going to use this throw audio right now, which actually reminds me, I don't think we ever set the lift audio. Let's go over here. I don't think we ever set the lift audio, so let's just go back real quick. Yeah. Within our player folder, our audio, we should have a bunch of sounds that you got. So you can pick one of these. I think it's this, huh? Let's try this. Huh? Yeah. So I kind of recorded these as a little game jam thing and modulated them. So technically that's my voice. Adjusted a little bit. So let's just go back to our lift state. I'm going to put this in here as a lift audio. Let's just test that real quick. This is going to mean my video is going to be a little bit disjointed here, but there we go. Little sound effect. Okay, back to the carry state. Go ahead and go back to this script. We're going to have a throw audio for this one, so when he throws it, it's going to make a sound. And then we need a couple variables. We only need really two variables to kind of track. So one is if it's walking or not. So this is a Boolean variable, walking, bool equals false by default. And then we'll have another variable that we'll call throwable. That's a weird word to try and spell. This is our throwable, okay? So we'll have a reference to that because we're going to need to be able to kind of trigger some things on that. We also want a reference to our idle state. Okay, so I'm going to hold control and drag that in. And we do want a reference to our stun state. Okay, this is going to come into play later. But by default, once you've thrown an object, we can just enter the idle state. I don't know that I've really spoken to this in the past, but idle state is a good state to enter because from the idle state, the player can do just about anything. Okay, so if you're walking and you enter the idle state, then it's just going to enter the walk state, basically. So there's no need to code like, okay, if we're pushing a direction, we're in the walk state. Don't worry about that. Just keep your life simple. Just do it on the idle state. Okay, so in here, when we enter this state, let's just go ahead and we can update. We can do player.update animation. And by default, we're not walking, or we don't want him to be walking. So similar to our idle state, we'll just assume he's not walking. So we'll also set walking to false. Okay, and just play the carry. And of course, you know, our update animation adds on the direction. We didn't refresh on that, but it does add that on there, so you don't need it. It figures out which way we're facing and adds it. We're not going to deal with our exit function right now, but we will need to deal with that. But let's just come down to our process. So this is where a good chunk of this state happens. So we'll say, well, what do we need to do, right? What am I going to write here? We're just going to check if we're pushing, if the player is supposed to be walking, let's make him walk. If not, we'll make him stand. Okay, it's really simple. And it's all going to result in us setting our player velocity. So we can do that first, actually. So player velocity equals player direction, player.direction, because we've got that on our player, multiplied by our move speed. And actually, even at this point, if I run the project and pick up this pot, we should be able to move. He's just going to be like moonwalking. Okay, there we go. We can move. So this is enough to make that happen because our direction code happens on our player constantly. So we always have a reference to that. But we do want to do different stuff, right? If he's walking, we play a different animation. So here we go. If player.direction is vector20. This is when he's not walking, okay? So if he's not walking, then we're just going to set our walking to false. And then we're going to update our animation. In fact, it's going to be just this line of code, player update animation carry. And then we'll do an elif. We could do an else, but if we do that, we're going to run into weird animations, you know, weird opportunities where the player could end up looking just like he did when we just tested a moment ago. Okay, so we'll say player set direction. And let's just do a quick refresh on this. The set direction, it tries to update the directionality of the player, and if it changes, it returns true, otherwise it returns false. So if the player direction changes this frame, then we need to update our animation. Or if walking is false, flays. Another one of my favorite words in Godot, flays. So if walking is false, the reason we check for this is because if walking is false, it shouldn't be, because otherwise we should have no direction, right? So if the player direction is not 0, then walking should turn to true. This is a way for us to catch that, oh, he's changed from idle to walking. Okay, so either he was idle and he started walking, or he was walking and he changed directions. In either of those two cases, we'll say player.update animation. And in this case, we'll do the carry walk animation. And then we'll also just set walking to true so that we don't keep looping through this. Hopefully they're always awake. Okay, let's go ahead and just give this a whirl. So this should actually make it so that we've got all the animations we need. Yep, there we go. Okay. And we can't do anything else at this point, but that's a good start. Let's come down here. Let's come down here to our handle input function. Obviously, the other thing we want to do is throw the pot. This is where it gets kind of tricky. There's a lot of ways we could throw the pot, but the first thing that we can do easily right now is we can detect for the button presses that would cause this, okay? So here in our input event, if the event is action pressed, not action, just action pressed. Okay, so if it's the action pressed, if it's the attack button, or if the event is action pressed, and then we can just do like our interact button. Those are probably the two we want to use. You could use others if you feel it's necessary. So if either of those two buttons are pressed, what we're going to do is actually we're just going to return the idle state. And the reason we're going to return the idle state is because we will handle throwing the object in our exit function for this state. And then that way we can kind of throw the object, but we can also drop the object, because there is another way to exit this state, right? And that's if we take damage, we're going to exit this state. Because if you recall, I mean, let's look at our player script. When we take damage, okay, we emit a signal, and then where's our stun state? Our stun state, when it hits, meaning when it loads for the first time, it connects to that player damage signal. And anytime it gets that player damage signal, then it, let's see, where is it? Right here. It forces the state machine to change its state to the stun state. Okay, so that means that any other state that it was in will call its exit. So that's kind of convenient. It can also be a bit tricky to work around. I don't know. So I don't know if there's a better way you want to do this, but I'm sticking with it for this. So that means in our state carry, if we throw the object or drop it in our exit condition for the state, then we don't have to do overly complicated code to try and figure out what to do with it. Or what I wouldn't want to do is within our stun state, drop an object or worry about objects. I don't want to worry about that in here. because then it gets confusing, right? Because then you're like, you know, a year down the road, you're like, okay, where do I drop the object when they get stunned? And you have to go to the stun state to find that. That could be confusing. And I don't really like that. So I'm trying to keep this as clean as possible, all right? But let's just go ahead and test this one bit of code. What should happen is the player's going to return to his normal states, but he's still going to have the object kind of stuck to him, okay? So let's pick it up, and then let's just push that button again. Boink, back to normal. Now I can do everything just with a pot on my head, which is a great feature, especially if you're Mowgli from, I don't know if you guys remember that old Disney movie. What was it? The Jungle Book? He's going to fetch the water. Okay, so we've kind of come this far. We have a functioning state as far as being able to carry an object, but obviously, even though the state doesn't say it, throwing is going to be part of the state. I don't think it's worth making a throw state to handle it, because again, we'll just handle the throw right here in our exit. So I'll just make a comment to throw object. Okay, so let's put some code in here then to handle this. Really, we could just say throw object, but I mentioned stun, and when you get stunned, I don't want it to have quite the same behavior. Instead, I want them to drop it. So we'll have two variations, throw or drop. And what we'll do is we'll say if we have a throwable, we should, but let's just check to be safe. If we have a throwable, we need to do a couple things. We need a way to detect and set a throw direction. Okay. Then we need to see, were we stunned? Oh, that's not a comment. And if we were, that, like, if so, let's drop item instead of throw it. Else throw item. Okay. So let's go ahead and put a pass in here so we get rid of that warning. Now, we do have a flaw in our full system. It's going to be really hard to see if we were stunned, okay? And I implemented this two different ways, and then shortly before recording this, I changed it. And I think I've come up with probably the safest solution, but we want to modify our state machine. So I'm going to just go to the state machine. I just clicked on a little script for our state machine. Now, what we do when we change a state, let's go down to this function, change state, we get a new state. If the new state we pass in is null, or it's the same as our current state, then we ignore it, okay? And then if we have a current state, which we always do, except maybe the first time it runs, then we exit that state. Okay, so this is the point at which this carry state is going to call this exit code, right? Right there. But you'll notice with this new state, we haven't done anything with it other than check to see if it's valid. So this state would have a really hard time referencing that. And rather than try and devise some fancy way to do that, what I want to do in our state machine is I just want to extend this so that we have a reference to whatever the next state is going to be. And so let's just come up here to the top. We've got previous state, current state. Let's just add next state, right? Why not? Next state. Pretty simple. And so far, the only place we're going to use that is that this is in our new carry and throw state, right? So here, before we check our current state and exit it, we just need to say our next state. We need to set that equal to new state. Okay. And there we go. That's all the modification we're going to make to our state machine. Set this next state here and just add it to our state machine. So now when we're in our state carry, now we can check, okay, what's our next state? So you remember earlier we set a reference to our stun state. Okay, so we're going to ignore the throw direction for now. Let's just do this. Were we stunned? If state machine, because we do have a reference to our state machine in all of our states, dot next state equals stun. Okay, if the next state is the stun state, the same as that one, then we know we can drop item, okay? Then we'll have an else statement. Else, this is where we will throw the item. Like so. Okay, and so that's what our exit function is going to look like. We just need to populate these little bits of code, but these all are going to rely. Oop, I already got that in there. These are all going to rely on the throwable that we're holding. Okay, so that script. So we do need to work on that script before we can finish this here. Okay, so let's go ahead and just save that, and then we'll work on our throwable next. So let's look at what we need to do here, and let's move back over to our throwable script, because we're going to need to make some updates and some changes. Well, maybe not changes, but just updates, right? There's some more variables we need to track, and there's some more situations that need to be handled, and we're going to handle most of them here from this point on. So one thing that we need to do is that we mentioned in our state is we need a throw direction. Okay. And this is going to be a vector2. And this is just right the direction that it's being thrown. And we'll set that from our carry state, but we'll use it here to be able to move the object and to throw it. And then we also need to keep track of a few other things. So what's going to happen is this is a little bit hard to demonstrate, but as we throw this object, it's going to be moving across the screen, right? Like this. But we don't really have height, because if we move it up and down and we're actually moving, like, say, the hitbox, then that's not quite right, because really we only want it to hit what's in the direction of the throw. Let's just assume that it's being thrown to the right. So one thing we can do is we can take our sprite 2D and we can move that. So when the pot moves, the sprite, not the sprite shadow, but the sprite slowly falls to the ground. Okay. And we can do that through script. And so we're going to have kind of like an artificial new axis to our pot. And we're going to refer to that just as kind of like the height. So if we go back to our script, we already started with this throw height strength and throw starting height. Okay, so that's that fake height. So 49 is like, we're going to move this pixel to, it's going to be, I guess, it's probably going to be negative 49 pixels, okay? So that's kind of like what that means. 49 means put it this high when you throw it. And then the throw height is just going to be like a strength. How much up will it go? And then the gravity is going to control what it will eventually fall back down, okay? So in order to do that, we need to do a couple things. We need to keep track of the sprite of our pot so that we can move it up and down. And we need to keep track of a velocity up and down, as well as a way to detect when it's at the ground so that we can destroy it once it hits the ground. And so we'll grab those things. So first of all, let's start with the object sprite, not just object sprite, but variable object underscore sprite, which is just a sprite 2D, right? And then we want to keep track of, let's see, what did I say? The vertical velocity. So the new variable will be vertical velocity. Okay, and that'll be just a float. And it'll start at 0. Or be default to 0. We also want the destroy height. Maybe we can call this ground height, actually. Let's do that. So that's the height where the pot hits the ground. That'll be a float. And by default, that will be 0. Okay, so these things all go with the throw, right here with this throw direction. And then lastly, we do want a reference to an animation player. The animation player that's on our object, okay? So the reason we're not doing an onReady variable for the animation player and for the sprite is because, let's see, animation player. Is because, remember, this script is on the throwable. So there's, in this scene tree, we don't have access to those items. So we're going to grab them dynamically from the parent object when it's spawned. And it is possible that these won't exist. And we'll put some basic code in place to handle that. Okay, but these are the variables that we need to keep track of to make all this work. Save those changes. Okay, let's look at our ready function. So let's grab a few of those and let's do a little bit of work here. So one thing that's going to happen is we need to grab that sprite. We call it the object sprite, right? And you know, there is a function we can use to get nodes that I don't normally use, and we'll use that in this instance. So we're going to say throwable, okay, which is going to refer to what the parent, whatever it's applied to. In the case of our pot, we've got our throwable here. The throwable object is the pot. Okay, so we'll say throwable dot get node. And get node, well, I got two dots there. Get node allows you to pass in a string, which is the name of the node that you want to access. So I'm just going to say sprite2d. And so this is going to look in the scene tree for sprite2d, and there is one, and that's the object. So remember how I said earlier, like you're going to have things named a very specific way and in a specific place for it to work. This is one of those instances, okay? This is how you could do it in a more rigid fashion. Next, we need the destroy height after we get that object sprite, or what we ended up calling the ground height, I think, right? So the ground height is going to be equal to, we're going to set this because we have it at 0, but I just want to demonstrate this. Let's look at the pot. See, the sprite for the pot is at this position. It's at a certain position where this is on the ground. And if we look at the actual position it's at, that's a -9 on the y-axis. Okay, and that is going to be different based on different sprites, I would imagine. So we don't want to hard code that. So going back to our script, we'll just look at the object sprite. We're going to assume that we've set the object sprite initially to look as though it's resting on the ground, and we'll take that y coordinate and use it for the ground height. So the ground height is the object sprite dot position dot y, not x, y. Okay. And then let's do this. Let's get our animation player. So we go animation player equals throwable. And there's another way we can find a thing, actually. Let's go ahead and use this. It's find child. And actually find child is a little bit safer. We might end up using it on the get node. Okay, so find child. We want to find a child with the name AnimationPlayer. Okay, AnimationPlayer. So let's look at the difference between these really quick. So get node. You see it returns a node, fetches a node. The node path can either be relative path or an absolute path from the scene tree root to a node. If it does not, if path does not point to a valid node, generates an error and returns null. Attempts to access methods on the return value will result in an error. Okay, and then let's go back here to find child. Find child is similar. Finds the first descendant of this node whose name matches the pattern, returning null if no match is found. The matching is done against node names, not their paths. So there's a difference there, right? One is get node is a path, and find node is a name. Another difference is, so one difference is right, this sprite2d, it's going to look right here for a node called sprite2d, okay? Within the, just because that's a path. If we didn't want it to be under the, like if we wanted the child of the static body 2D, then it would be like static body, you know, like this. It actually provided me that path. Okay, that's kind of how get node works. Find child is more processor intensive, but it's more flexible because it's just going to look for anything. There is one other difference I want to point out. This one it generates an error if it doesn't find it, and it returns a null. The find child doesn't generate an error. It just returns a null value, which is a little bit better. So actually, let's change this to find child. And it should just return the first one that it finds, right? The first descendant. So that's still good because it's still going to find this, even if there's other sprites. Okay. So a couple different ways to get some objects. Now there is a possibility that these could be null, and that's okay. But we're finding those child nodes and getting access to the things that we need to do this, okay? Kind of a lengthy explanation of these and some different things that we're doing here. Okay, let's look in our code a little bit more. We've got our player interact. This is looking pretty good, actually. Let's remove this. I'm going to remove this comment. And I'm going to remove, well, I'm going to leave that one because we are going to come back to this, okay? But I guess the next thing then is we want to create functions that will throw or drop the item, okay? We're going to make them right down here. So the first function is called throw. And what throw is going to do is it's going to just initiate this whole process, okay, and get the object in a state where it will move. And so we got to remove it from the player and give it like a velocity and stuff like that, okay? So One thing though is we didn't make this a rigid body 2D, so we're not going to be actually giving it a velocity in the same sense that we did like with our player. Okay, we're going to be doing it all through code, but that's okay. So we'll say, first thing is we're going to say throwable, because we need to remember the first step was to remove it from the player. Okay, and so that means similar to when we added it to the player, we had to remove it from the scene tree that it was in. So we'll say get parent dot remove child, and then we're going to just remove the throwable. Okay, and then next we need to add it somewhere in the scene tree. And we actually have an issue here. I think it's this line where I had an issue. So I guess what we would do is we would say, like, if we're throwing it and we're looking at the scene and we've got our player here, we want to add it to the level, to this node, right? At this level, which is going to be the parent of the player. That's how our game is built to work, because we always add the player to the level when he spawns in. Okay, so in order to get the throwable in the right place, we just want to find that level, and we can do that fairly easily. We'll just say player manager dot player, and then just get parent. Whatever the parent of the player is, it should be fine. Okay, and then normally we would say add child, but because this could be happening as a result of a signal, let's look at this. This is one of these things that's kind of hard to explain, but we've got the stun, which could change the state, right? And this all could happen as the result of a signal when the player takes damage. And because of that, because of the nature of where this happens in code, we can't call the add child directly. We need to use call deferred, and we've done this in the past. But so call deferred. And what call deferred does is we give it a string name. So in this case, it's add child. And then we give it the arguments that we need to pass in, which is the throwable. Okay, so this is the same as calling add child with throwable, which is what we've done up here, like this right here, right? Add child throwable, except it's deferred, which means that it will call during the next idle time. Okay, it's going to just happen like the next frame. So there's a delay, but it's going to be imperceptible. And then we need to deal with the position. You remember when we moved the position to the player, we had to set it to vector 0. But in this case, we're going to have to kind of do the opposite. We're going to have to figure out where it is in the level. Okay, and what we'll do is we'll say throwable dot position equals player manager dot player, and then we'll get his position. And we're not using global position here, even though I normally do, because in this case, they both have the same parent, and we can know that for certain because of how we're doing the code. So the relative position is fine. Okay, and then one other thing we'll do here is let's get our object sprite, and we're going to set its position Y. Okay, so in fact, let's just review this real quick. So if we're looking at the pot, we want to take the object sprite, where are we at? Right here. And we're going to set the Y to whatever that throw height should be. Okay, so let's go back to our script. And that's going to be, our throw height is going to generally be a positive number, but Y, X, and the way that the Y direction works, up is negative. So we'll say negative throw starting height. There we go. And then let's go ahead and set up some other things. So we'll take our vertical velocity and set that equal to negative throw height strength. And then we're going to need to do a few more things, but we'll wait on those. So next up, we're going to have to kind of like enable physics. And we're actually literally going to do this in the physics process. And then we're also going to have to like enable the HurtBoxes and stuff like that. Okay. So I hope this makes sense where we're going so far. We've removed, when we call throw, we're going to remove the object from the player and add it to the same level, and then just set its position, the position of the sprite, as well as this vertical velocity. The reason we're setting the vertical velocity to the throw height and not just using one variable is because the throw height is this, the throw height strength is this value that you set, where is it, right here? Okay, which is like, we probably could have called this something related to velocity, but the vertical velocity is going to track the actual velocity, and we're going to manipulate it each frame so that it'll go up and down. Okay, so let's save this, and then let's come down here. We've got our throw function. Let's also create a drop function. The drop is going to be more or less the same, but there's some differences. We could try and do this in the throw, but I think it's easier to make it separate. I guess we do need to repeat some of this code. Let me copy that, paste it. Okay, and I guess we also need this position code, and probably we're going to do the height, but we'll do it a little bit differently. Same with this strength, but let's just go ahead and copy these lines. These functions are so similar, but so for the drop, let's see, the object position Y, I don't really want to set this throw starting height. Instead, I'm going to set it to -50, which is just above the player. So this one's not going to be configurable. And then we'll set a different velocity, and it'll just be -200. Okay. So it's going to go higher, probably. I mean, the default throw height is 100, right? So this is going to go higher than the default throw. Whoop. And we could, I mean, you could make this an export variable if you wanted to, so that this, when you drop it, it flies up in the air a different amount. And then similarly for the throw speed, I'm gonna just set that to 100. This is not a variable or a value that we're changing anywhere else normally, but in this case we're going to set it to a fixed speed. Okay. Now, what we're gonna do is, in order to make this work, we need to utilize the physics process. Okay, so underneath ready, let's go ahead and add a physics process function call. Okay, and this happens, you know, every physics tick in the engine. And we don't need to do a whole lot here. We need to move this sprite up and down and in the direction, you know, up and down to simulate the gravity, and then not move the sprite, but move the whole object in the direction, right? So let's start by manipulating this sprite. So object sprite dot position dot y, and then we'll just say plus equals vertical velocity times delta, because remember, we're doing movements that are time sensitive, and so we need to use the delta. This is the change in time since the last frame. It's how much time has passed. So we're only going to move it by the velocity for that amount of time, okay? And then next, we can check to see if sprite hit ground, you know, quote unquote ground, okay? Which is going to be that ground height value we set. And if it did, then destroy it. Otherwise, what we can do is we can increase that vertical velocity or adjust it. Okay, so we'll say vertical velocity plus equals gravity strength times delta. So it's going to change the velocity by the gravity strength. And again, this is time sensitive. And then we'll also update the throwable object position. So we'll say throwable dot position plus equals throw direction times throw speed times delta. All these things are time sensitive, okay? So we're going to ignore this check right here. Let's save that. Now we haven't really called this throw functionality anywhere yet. So let's go back to our carry state. So here we've done some checks. So let's fill this out. We need to calculate the throw direction, and we'll set that in the throwable. So this is pretty easy. There's a couple ways we could do it, but the simplest way would be to say throwable dot throw direction equals player dot cardinal direction, because that's always going to be direction. The downside to the cardinal direction is it's up, down, left, or right. It won't be diagonal. Okay, so we might need to adjust this. And then if it's a stun, if we exited the state because it was stunned, then we'll say throwable.drop. Otherwise, if it's not, then we know it was a throw, so then we can say throwable.throw. Okay. In addition, when we throw here, we've got our throw audio. Let's go ahead and play that when we throw it. So we'll just say player.audio stream. Audio.stream equals throw audio. And then play that. Player.audio.play. Okay. So we should be at a point where we're kind of doing this. This is such an in-depth little bit of back and forth that we may have missed something. But let's give it a go. Let's see what happens. Well, the pot just fell. It's still there, but we saw it fall off the screen. And there's a pretty obvious reason why, actually. So if we look back at our throwable, when we added the physics process, we forgot one thing. We don't want to do this all the time. Now we could put a check in here. We could put a condition and just say, like, if it's been thrown or something. But there's an alternative way that's a little bit easier, actually. We only need to run the physics process once the pot has been thrown. And for the rest of the lifetime of this object, we don't need to. And once the pot's been thrown, it's going to eventually hit something and break. Okay, so let's just do this. Let's come down here in our ready function and we'll say set physics process. And in here we can provide a Boolean true or false. So if you say false, okay, then it's now the pot shouldn't fall. But we do have still one more issue, I guess, right? Because there we go, we threw it, but we didn't enable the physics. We got to re-enable the physics process. Okay, so come in here and let's just go to our throw and our drop functions. See, I made a comment about this. We'll enable our physics process, okay? And then we'll do the same thing with drop. Except that's not enabling it, is it? We got to make that true to enable it. Okay. Go ahead and save that. Let's try this one more time. Oh, man. Okay, what did we miss? We're missing something. And I think the issue actually is in our carry state, because I don't think we have ever assigned the throwable. I'm gonna go to the player scene or script. Yeah, so see here in our pickup item, this is where we passed the throwable in, but we never saved it. So let's see, let's make sure we got a reference to our carry state. I don't think we did. So let's do this. Let's go to our player. Okay, so I'm in the player script, we've got the player scene open. We've got our carry state. Let's just grab a reference to this here. And then whenever we initiate the pickup item, we got to do this one little step. We'll just say carry.throwable is going to equal t, this thing that we passed in. Okay, so now we have a reference to it. And I think this should fix the little issue we have there where it's not throwing. Awesome. Okay, it went, and you could see that the shadow just kept going, and the pot fell forever and ever. Okay, so that's just because we didn't destroy it. So let's go back to our throwable and to our physics process. We didn't do this part here. Check if the sprite hit the ground, then destroy. Okay, so this is actually pretty simple. We'll just say if object sprite dot position y. This kind of represents the height, right? So if that position y is, in this case, greater than, because you would think it's less than because it's got to be lower than the ground. But again, the coordinate system's reversed in this direction. Up is negative, down is positive. So if the position y is greater than the ground height that we stored, greater than or equal to, then we'll destroy it. And we're going to make a function. So I'll just call this destroy right here. And we're good to go. We don't need that pass, but sometimes it's nice to see that. Okay, so let's create our destroy function. Go ahead and save that. Throw, drop, destroy. Put it right down here. Okay. So what does our destroy function need to do? First thing we can do that's maybe somewhat obvious is disable the physics process because we don't want it to keep falling. Not just physics, but so set physics process to false. Yeah, that way we'll stop that because we're going to play an animation right? So we want it to break and then just like stay on the ground and play the break animation. So then we'll just check if we have an animation player, because we might not. If animation player, then we will say animation player dot play destroy. It better have a destroy animation. And then we can just await animation player dot animation finished. Okay. Then when the animation is complete, or if they don't have an animation player, then we'll grab our throwable and we'll queue free it so we can just get rid of it. Okay, so throwable.queueFree. Okay, simple as that. So with those changes, let's go ahead and run the project. And let's see if our pot breaks. Nice. Okay, played a little sound effect. Let's do a couple things. I want to go to scene 2. I'm going to duplicate this pot. Maybe just once. And then I'm also going to copy this, and let's open another level scene, the one with some enemies. So let's see, area 1, let's just open scene 1. There's a lot of enemies in here. And we'll paste a few pots. Oops. Didn't want it to be a child of the other one. Let's just go ahead and duplicate this. Okay, I've got 5. 1. An interesting configuration of tightly packed pots. Right where the player spawn is, which is probably not a good idea in case we test this level directly. Let's just scoot them over. Okay, so there we've got multiple pots. So let's try a few things. Let's try getting hit by an enemy while we're holding a pot. Let's see what happens. Okay, pull them up here. Oh my gosh, okay. Nice, it dropped, okay. Oh my gosh, it's a good thing I haven't implemented the being able to die just yet. Now I wish I could throw it at that guy and hit him, right? I mean, that's the next step. And you'll notice I just got stunned and was able to finish picking up the object. I think that's kind of okay. I don't know. Let's see what happens. This is kind of a tricky one. Yeah, seems okay. Okay, doesn't seem too buggy. So let's work on this. Let's make it so that our throwable object can damage the enemy and see if we can get that to work, okay? I'm also not sure, actually. Let me run this one more time. There might be one more thing to fix. Let's just check. Did it make the sound effect? I didn't hear the sound effect. Maybe we didn't do that. Okay, so let's go into our scripts. First, let's look at that sound effect. So if we're looking at the carry state, it's probably because we didn't set one up. So let's go to our player and let's go to carry, throw audio. Didn't add one. So easy to fix. Just go down to our player audio. And there is a throw sound effect that we can use. Okay. And now that that's fixed, let's go back to our throwable. So once it's been thrown, I want to do one thing in a very specific way. I think if you throw the pot, it should hit the enemy. But if not, if you drop it, then it probably shouldn't be able to damage them. This is optional, okay? So what I'm going to do that is I'm going to go to my throwable throw function, I guess, right? Where's throw at? Right down here. And I already made a comment. We need to enable the HurtBox. And I think we already grabbed a reference to that. Yeah, there it is on the onReady. Okay, so we're good there. So let's just say HurtBox dot monitoring equals true. And actually, we need to set this deferred. Remember how we had to do call deferred on the player or the get parent and adding child? Yeah, not on the get parent. Remember how we had to use call deferred on the add child? We actually need to do this with monitoring. So we actually need to do set deferred here, which is like call deferred. It's just different because we're setting something instead of calling something. So set deferred, and the property we're going to set is monitoring. Yeah, like that. And then the value we want to set it to is true. Okay. So this will take care of that. And then we also want to do one other thing. We want it to destroy. We don't want it to keep going if it hits an enemy. So we'll go go to our HurtBox and we have a, do we have a, I don't think we have a signal, do we? So let's look at this actually. Let's come up here. Let's go to our HurtBox script. Let's just add a signal. And we'll call it did damage. And this is pretty straightforward, right? If it does this thing down here, then it also did damage. So we'll just say did damage.emit right here in this bit of code in our HurtBox script. Save that. Go back to our throwable. Okay, where's the throw at? Right here. So HurtBox.didDamage.connect. And in this case, we can just connect that destroy function we just made. Now, if we run this, then we should be able to throw this at the goblin here and do some damage. And I just picked up 2 at a time. You notice that's kind of weird. And now I'm like forever holding one. But there we go. That did do damage to that goblin and it killed him. Okay. So that's working. We have a little bug here. I think that's probably related to the... this happens sometimes. I've got a keyframe somewhere that's outside of the animation range. I haven't been able to find it. I literally have looked multiple times. Okay, so we'll fix the bug of picking up 2 pots, but this works. Now you'll notice we did this only in the throw. If you wanted this to happen with drop, you could add it there as well. Okay. The other thing that we could look at is I want to look at my carry state. Now, when we throw this, we're setting the throw directional to the cardinal direction, which if we run the game and we like try and run diagonally, I think it would be nice to be able to throw diagonally, but it just throws it straight. And so if you wanted to be able to throw diagonal, we could do that. We need to kind of have a conditional, because if you're not walking, if you're not pushing a direction, meaning you're just standing there, then we need to get the cardinal direction, right? But for sake of demonstration, let's comment this out and let's get our throwable throw direction a different way, because we do have a direction on our player. So we can just say equals player.direction. Okay. Now this should work while we're walking. Let's just give this a quick test. So now if I'm running diagonal, there we go. Threw it diagonal. But then if I pick it up and throw it, it just drops on his head, which maybe you want, maybe you don't. But what we can do then is we can just say, we can put this in a condition. So we can say if player direction equals vector 2.0, so double equals, right? Then we'll do the cardinal direction, because we always store a cardinal direction. Even if there's no directionality and the player's not moving, we keep the direction he's facing. That's what the cardinal direction is. Else, we'll set it this way. Okay. And then we could even, so now let's just test that. Actually, so test, let's run this. So now if I grab a pot and I face up and I'm not walking and I throw it, he throws it up. And then oh, hello, picked up a pot and talked to him. Okay, now I can throw it diagonally as well. Okay, and if you had like a thumbstick on a controller and we're walking at slightly different angle, it should honor that same angle. The other thing that we could consider doing is when we drop this, we might want to actually modify the direction. So we could reverse it, right? We could say throwable.throw direction equals, well, and we'll just take the same thing, throwable.throw direction dot rotated, and then here we can just pass in pi. That's like going to be 180 degrees. I think this will work. So let's run this and grab one of your pots. Give me that pot, bro. And then we'll come up here. Let's let this guy hit us. It should, there we go. Went the opposite direction, went behind us, which I think is kind of fitting, you know? And of course I've got multiple pots now and it's just all wigging out. I can't kill this stupid guy. Now I've got 3 pots and only one of them fell. Okay. So now that we've refined this, let's put that to bed for now. I mean, this is plenty of ways to drop or throw. Okay. Actually, I like that space there. So this is good. I mean, if you've got a couple different ways that you can handle this, and you could combine them all. You know, you could combine the throw and the drop into just throw, and even when you drop it, just make it a throw, and then it would probably hit the enemy if you're facing him. You know, things like that. But there we go. We've got some good options. I'm kind of getting tired because this has been a long recording session, so I hope this isn't too long of a video. But I think this is a feature that most people are going to want, and we're really doing a lot. You know, we're doing a lot in just one video. So I hope you guys appreciate this one, and it makes sense. But let's go ahead and address the issue with picking up multiple pots. I mean, that's kind of simple and straightforward, but maybe kind of confusing at the same time, especially because we haven't really done anything like that. And this, to some degree, this issue stems from how we're handling the interactions, though I don't think we wouldn't have had this issue if we handled the interactions differently necessarily, unless we had somehow made it so that, you know, we were casting array or had a very narrow window of being able to detect items to interact with. But I don't think that's good for the user experience either. So what we need to do really, in a nutshell, is just say, like, when we get that interact pressed from the player, we need to check if it was handled. And this is kind of similar, you know, there's this unhandled input or handle input, right? And Godot has some built-in things where you can set an input as handled. So we're going to do kind of something on our own within our player manager. So let's look at some of our code in the player manager. Here's where we will start. And let's see, let's go to the top of our player manager script here. So we've got our interact pressed. We've just got a couple things in here. Let's just add a new variable, and we'll call it interact handled. And this is a Boolean, and we'll set it equal to false. Okay. Or actually, no, true. It should be true by default. And then anytime we interact, so we have, I'm going to change this. I wonder if I'm using this function anywhere. Let me do a search for that. I don't think we are. Nope, this is the only place in the whole project. I'm just going to change this to interact. Okay. Now, when we interact, we're going to say this. We're going to say interact handled equals false, and then we'll emit it. Okay. And then what that means is we can set this to true, but it'll always get set to false the next time the interact is pressed. And you'll see how this helps us in just a second here. Now, what we'll do is let's go to our throwable. And in here, we have this code where we react to the, let's see, player interact function. Where is that at? Here it is. Okay. We made this comment. We pick up pot only if, you know, or pick up one only, right? And so what we can do is we can say if player manager dot interact handled equals true. So if it's true, if it's been handled, that means we don't need to do anything. So we can just return. Otherwise, we'll pick it up. Before this can work, though, we do need to update where we're setting interact handled. So I'm going to do a search for player manager, and I did Shift Control F. Player manager dot interact. Let's just search for that. It should find in it all of our code. You can see down here we have connecting, disconnecting, handled, connect, disconnect. Here we go, emit. See, this is a mistake that we made early on. It was just, I don't know about a mistake, but just kind of the easy way to do this. We only call that interact pressed, or we only emit it in two places, and we should have only ever emitted it from the player manager. So we've added this interact function, which will emit it, and it also will set that to false. If we would have built it this way originally, it would have been easy to add onto it. Fortunately, again, we've only done this in two places. So here in our walk state, if the interact is pressed, right, then we do it, we allow them to interact. But instead of doing this, let's just say player manager.interact. Easy peasy. And then we'll do the same. It's in the idle script. It's the other place where the player can interact. So just delete that little bit right there. Okay, so now anytime the player presses the interact button, it gets handled with our new interact function. And then by doing so, now if we run the project, I shouldn't be able to pick up multiple pots at the same time. Let's walk right in the middle of them. Kill me now. It didn't work. I'm not sure what did we miss. Okay, let's look at this. Player manager.interact. Interact handled equals false. Interact pressed emit. Let's go back to our throwable. Oh, we do need to do one more thing in here. So by default, we never set interact handled. This was the key. I was getting there, but I didn't get there. We do need to set this. We do need to set this to true once it has been picked up, right? So in this case, you only need to do this check on objects where it matters, which might be a lot of things with interaction, but we can just simply go right here. When we pick it up, then we'll just say player manager dot interact handled equals true. Okay, there we go. So at least I demonstrated that the bug worked one more time before we test the fix. So now if I walk right in the middle, there we go. Only one pot can be picked up. Okay. Simple fix-ish. It requires some discipline. If anybody has any thoughts on how this could be done in a different fashion that's better, I would be open to comments on that. But I think this is a good enough solution for most projects, especially if it's not too big. Okay. All right. So I think we've actually built a fairly robust throwable object. I mean, it's 120 lines of code in here, counting spaces, which I give plenty. But I want to just try one more thing. This is the moment of truth. I want to look at something. We've got a pot, and we've made it throwable, all because it's got this throwable thing in here, right? We haven't added anything extra to the pot. So the moment of truth is let's go down, and I'm going to go pot. I can't remember where this is. So right click here and just say show in file system. I mean, I kind of remember. I'm just getting tired. You guys are lucky you can like pause and maybe watch this tomorrow. If this is too long, let me know. I'm curious to hear what you guys think. I mean, I've been doing only long videos, but this one's kind of long. Let's open up our plant scene. Okay, so if I come in here and I do Shift Control A, and if I add a throwable node, okay, the question is this going to work? We do need to add a collision shape, so let's add one of those. Collision shape, so we know where we can pick it up, and this can be a box. And we'll just make it a little bit bigger than the static body shape. And this has a couple things that are already set up, like we already do have a destroy animation on our plant, which is nice. So it actually should work pretty good. But we did condition in our code, we did build for a condition where there is no destroy animation. Okay, so let's just go ahead and run that. We've got a few plants. So if I come up over here to the plants, heck yeah, I can definitely pick up a plant and I can throw it. Okay. So there we go. That's the tutorial. There is one thing that we left off. I'm going to go ahead and just mention this now, and we'll probably build this later, but you can do it as well. You could add the ability for these to drop an item when they are destroyed. We didn't add that. We have an item dropper. It would have been somewhat trivial. We might want to make it so you can't do both of those. It's pretty trivial to add an item drop, but I realize the item dropper that we currently have is too simple for what I would want it to do because it's a specific item. Okay, I'd want to build it to be more like our enemies that can drop a random assortment of things. So that's something that you could try extending on and adding on your own, or you could wait until I eventually get around to it. But otherwise, I hope you guys are enjoying this content, and please go ahead and like and comment on this video. It helps the algorithm, helps me get out there, and then subscribe to the channel if you want to see more. Next up, I'm going to be working on making it so that the player can die, because that's kind of a critical thing that we need to help round out our game. And following that, the most likely path is going to be to create our first boss encounter. And then I've got a whole big list and a whole slew of other features that people are requesting that I'm kind of thinking about and making plans for. Okay, so once again, thanks for tuning in. I appreciate everybody, and as always, we'll see you next time.